Okay, so we're in section 15 of the notes, and the deal about this one, I realize for some students, they look at this and they have very little comprehension of what's been presented to them. But what's been presented is a proof technique to you. And the proof techniques that have been printed to you is that, we're looking at these sum formulas over and we're trying to prove them. All right. So certainly, if I think back to what I did in the prior section with sums, I think I could probably write this down doing what I've done in the past. So let me just go back to my Sage. I'm getting a little better at this now because I've been practicing it, right? So let me just write this one down over here. And I don't know. Let me just take a look. I'll just say, reset. We've done this before, right? I'm going to, define a variable n. I think we've done this before, right? Again, just getting familiar. I'm going to assume that n is an integer. Now, let's say you can't remember doing this before. You go back and look in your notes and see if you can do it, see if you see that. All right. And then, I can say sum. I don't know what's going to happen, right? I, right? For I in 1 ... n. See what happens. Oops, made a mistake somewhere. Let me see what happens over there. You know what? I think I did make a mistake somewhere. Let me take a look what I did over here. And I'm going to go back over my notes a little bit. And this is something that, let's see, ellipsis, integer. Well, I guess I can't handle the n. Let me try that again. Sum I for I in 1 ... n. Let's see if it does it again. Yeah, it's still making the same thing. So I have to figure that out. But anyway, let me go back. Let me try another one. N to 10. 55. It did it. It just had trouble with the end there. I'm not sure why. Let me clear the screen. Looks kind of crazy. And what I want to do is I want to go through this again with you. We did principle of mathematical induction. Our main intent, though, is to understand the principle of mathematical induction. We did some really simple proof problems over here. I think we did a couple of these already. We went through some examples. We did them by hand. We went through principle of mathematical induction. Here's the problem, though. I'll be honest with you. A lot of times, algebra is really tough to do by hand. I mean, really tough. All right. I'm not saying it's impossible. I'm just saying it's really tough to do by hand. And that's where, using a computer algebra system can help you. All right. So, the problems that we've done in class and lecture were really simple. I mean, really simple to do. I mean, you may not agree with that because you don't have the algebra skills for it, but if you have the basic algebra skills, it's really simple stuff. Now, when you look at the homework, I'm going to say, one's really simple to do. But when you look at number 2, and this is where some students really don't pay attention, notice there's a footnote over there where they say, here you may want to use your calculator's ability to do symbolic algebra. And by the way, your calculator, if you have like a TI-89 or something like that, it can actually do, manipulations. And someone says, why would I want to use a calculator to do that? Because if you look over here, these expressions over here look really complicated. Like if I had to do n plus 1 in this thing over here, I would say that's a lot of work, right? Now 3 is even worse. All right. Why is that? Maybe I shouldn't say it's worse, but a lot of powers in it and stuff. I mean, there's square, not one square in it. Right. Yeah, it looks tough. Right. So let's go over the Sage code. All right. And what I'm going to do is go back to my Sage. I'm going to reset. N is a variable. By the way, once I reset, I have to redefine my variable. You might say I did it before. That's gone. N is, I'm going to assume that N is an integer. Nice if I could spell. All right. And then I'm going to, sort of say, what's this thing over here? Let me just do a copy paste. And I realize someone says, what's that there? I don't know. Let's put it down. Well, the reason I typed it in was I wanted to see what would happen when I typed it in. And someone says, I wonder what this guy is here. Let me go back on the notes and tell you where it is. I'm going to look in the notes, by the way. So I'm going to say it looks like number 3. It looks like n squared, n plus 1 squared, times 2n squared plus 2n minus 1 divided by, no, I didn't have the 12 there. You see that? So what I'm going to do is copy this again. And I'm going to divide that by 12. All right. This was why do you type that in? I'm going to see if I can type it in. That's all I want to do. Let's go back to the code. And I want to put this down now. And what is this doing over here? What is that? I want to see if I can factor that. All right. And someone says, well, could you do it by hand? I probably could do it by hand, but I'm letting my computer do it. Looks like it didn't do much, did it? Oh, by the way, that was already divided by 12. I'm sorry. Yeah. The second one is divided by 12. Yeah, I'm seeing that now. Oh, I'm sorry. You know what I did? I didn't read this. This is n squared, and then you got the n plus 5 to the 5th power. I'm adding on the next term. I want to point out what we're doing. We're using this for principal mathematical induction. We're taking this, we're adding the next term onto it. And that next term would be n plus 1 to the 5th power. So I took that term and I added n plus 1 to the 5th power to it. All right, an. I know it's tough. And I'm using my software to do it. I'm defining an, which is that, the pn. I'm pointing out what the pn and the problem is. This thing over here, that's an. And now I'm going to do a Boolean. And this is the part where if I had to do this by hand, this would be really tough for me to do. I want to see if n plus 1 is the same thing as an plus the next term on, which would be n plus 1 to the 5th power. This is what we're looking to do. This is what we're looking to do. So I'm going to hit the return. True. All right, I want to go back. And I used a computer algebra system to show that this is true. I want to use a computer algebra system to see if this one is true. All right. Again, I want to cut to the chase. My real chase is that, showing that, kth one gets to the kth plus 1 when it's a collapsing sequence. All right. Let me type down an is assigned n star n plus 1 star 2 star n plus 1. I'm just copying what I'm seeing in my notes. Star 3 star n squared plus 3 star n. If I make a mistake, I'll know that. Divide by 30. All right, that's what an is. Now what I want to see is I'm going to see the Boolean, if it's true or not. I want to see if, again, just like I did the prior one, I want to see if n plus 1, which would be a lot of work for me to do otherwise, is the same thing as an plus the next term on. What would the next term be? N plus 1 to the 4th power. Now, granted, if I make a mistake in typing it, I'm going to know that because we're giving you problems that are true. I'm sorry, to the 4th power. That wouldn't be true. True. Someone says, well, I don't see what they did. They actually looked at both sides and they said, are they true? You may want to try this by hand and see how difficult it is to do that by hand and see how trivial it was for me to do that using a computer algebra system. So this gives you some kind of, way to heavy lift. All right. It's important you learn to lift. All right. Important you learn to lift. All right. Thank you.